everybody. I hope you guys are having a wonderful day. Congratulations on making it to week 6. This is our last week of new content because next week is finals week. So I hope that you guys enjoy this last week and that you wrap up the semester strong. So the topic for this week is transformations, which are related to the concepts of congruence and similarity. So, in your guys' case studies this week, you guys are going to see some examples of situations where students develop the understanding that shapes are still the same shape, even if they're rotated. So, we saw some examples of this earlier, like in week 1, when we talked about the levels of Van Heil's theory. Um, where students are able to identify that a square is a square, even if it's rotated sideways and looks like a diamond, that it's still a square because it has 4 sides and it has equal side lengths and right angles. Um, so you're going to see some more case studies like that, as well as some discussions about what is it that makes two shapes the same shape. Um, so you'll see some of those case studies, and then you're also going to have a couple case studies that are not directly related to transformations or congruence and similarity, but they're good examples of how to help students develop mathematical reasoning and how to make geometrical arguments to justify their thoughts around um, different geometrical concepts. So, as you guys are reading through those case studies are kind of like a precursor to level 3 of Van Heil's theory. So remember, level 3 is the one where students are able to articulate proofs of geometrical concepts. So that's what you guys have been doing in your videos. And the case studies that you'll read that are not directly related to transformations are examples of how you can help facilitate discussions that help students start develop that thinking, even if they're not quite ready to write it out in a proof form yet. So those are the case studies you'll be looking at. And then for your video projects, some of you guys will be making videos about reflections and rotations and translations on the coordinate plane. And some of you guys will be making videos about what criteria triangles have to meet in order to guarantee that you'll have similar triangles or congruent triangles. So those are the projects that you'll be working on. And your homework is similar, where you'll be identifying similar triangles and congruent triangles. And then you'll also be drawing polygons on the coordinate plane and reflecting, translating, and rotating those polygons. So the key concepts we're looking at are congruence and similarity. And the way we're exploring those are with the transformations of translations, rotations, and reflections. So, first of all, let's talk about the definition of similar shapes and congruent shapes, because both of these words are to describe shapes that are the same, but the way that they're the same is different. So, kind of a little confusing there, but a similar shape is basically when you have the same, I don't know what word to use aside from shape, but it's the same shape, but it may be a different size. So these two pentagons here are both similar because they're the same uh, shape of pentagon, even though they're different sizes of pentagons. So the way that you formally define what similar shapes mean is that the corresponding angles must always be equal. So like this angle right here corresponds to this angle on the shape, and both of those angle measurements have to be equal to each other, which in this case, they're both 90 degrees, so that works. Same thing with these two angles. This one right here corresponds to this angle over here. And so both of these angles are equal. So that meets the equal corresponding angles. And if you were to measure all of these other 3 angles in both shapes, the angles would all be equal. And then the side lengths have to be proportional. So let's say, for example, that this side length is like a measurement of 1, and this measurement is a measurement of 2. Well, in order for these shapes to be similar, all of the side lengths essentially have to be 2 times as big. So like if this was 1 and this was 2, then maybe this side length might be, I don't know, 2.5, and this side length would have to be 5 because the proportion between the corresponding side lengths has to be consistent. So if it was essentially that this shape was double all of the side lengths of this shape, then they would be proportional and these shapes would be similar. However, if you were to take this shape and you made it like a little bit shorter, so like essentially like if you kind of like cut off a little rectangle here, then that would make the shapes not similar because some of the side lengths would be twice as big and some of the side lengths would be even more than twice as big. Because this side length that was used to be like maybe 2.5 and this was 5, if you cut off that little rectangle, this side length might be like 1 or 1.5, and 5 is not twice as big as 1.5, but the other side lengths would still be twice as big. So that's kind of the meaning of proportional. And that's like what that means is essentially that all of the side lengths, if you find the ratio of the side lengths of the two shapes, that ratio needs to be consistent. So that's the definition of similar. And then congruence is even easier because congruent shapes are shapes that are exactly the same. They're the same, like general shape, and they also are equal in their size. So they're equal in all ways. So their angles must be equal and their corresponding side lengths must be equal. So this side length right here has to be the same length as this side length here because those are the corresponding side lengths. So when you're talking with your elementary students and they're talking about shapes that are the same, you can introduce this vocabulary, even if it's just informally, so that they know what the different types of same shapes are. Because you can have congruent shapes where they're exactly the same shape, same size, all of those things. Or you can have similar shapes where the size of the shape may be different, but the proportions of the shape are still the same. Um, and this is important because for many students, especially those at like level 0 on the Van Hyle levels, they may not realize that these two triangles are the same because they're oriented differently. And for some students, the orientation of the shape seems to make it a different shape. And so being able to talk about congruence is important and being able to use transformations to justify congruence. Because this triangle right here has been rotated, which is one of the transformations we're going to talk about today. And even though the shape has been rotated, the angles are still equal and the side lengths are still equal. And so that's the reason why they're congruent shapes. So let's go ahead and talk about the different types of transformations that you can make in order to justify congruence. So the first type of transformation I want to talk about is a translation. So those two words are really similar, and the way that you can remember the difference between them is that a translation has like an SL in it, in the middle of it, and a translation is the same thing as sliding the shape. So you can translate shapes either horizontally or vertically or both. So if I were to slide the shape to the right 4 units or maybe 5 units, this would be the original shape and this would be the translated shape. Or I could slide my shape up 4 units, or I could slide it down 1 unit or to the left 2. Or I could do a combination of sliding it up and to the right. So maybe I might slide it up 4 and over 3, And that translation would be described as moving it to the right 3 and up 4, or vice versa. It doesn't really matter. You'll end up in the same spot either way. Because you could slide it to the right 3 and then up 4, and that would be the same. Um, so that's the basic idea of a translation. And usually students don't have a hard time realizing that these two shapes are the same because they're oriented in the same direction. And so it doesn't really matter to them usually, conceptually, if you move the shape to like a different spot. So, for example, if you were using like flashcards and having students identify different shapes based on these flashcards, if you had one shape that was oriented in like the middle of the flashcard and one that was up in the corner, if they were both oriented where the top of the triangle was towards the top of the card, they would probably realize that those were the same shape, even though they might be oriented in different spots on the card. So, usually for elementary students, the concept of translation is kind of intuitive. What some of you guys will be doing on your projects is that you're going to extend this idea of translation or sliding, and you're going to specifically look at what happens to the coordinates of the points. So remember, coordinate planes aren't introduced until sixth grade. And in sixth grade, they're just learning basically about how coordinate planes work. So when you guys are looking at what happens to the coordinates of the points, you're doing something that is more of a middle school topic, kind of like what I talked about last week. Um, but it's still helpful for you to look for those patterns and to understand how the length of the side lengths of the shape will be preserved, even if you change the coordinates of those points. So that's the basic idea of a translation is that you are basically sliding the shape to the right or to the left or up or down or both, or you're moving it to the right and up or maybe to the right and down or whatever direction you end up moving it. So that's the idea of a translation. Then the next concept that we're looking at, or the next transformation, is a reflection. So, a reflection is really important in elementary math because in elementary math, you work a lot with symmetry. And symmetry is essentially, well, I guess there's actually two types of symmetry there's reflectional symmetry and there's rotational symmetry, which are the precursors to the reflections and rotations that students will be doing later on in middle school and high school geometry. So, reflective symmetry is basically when you reflect the shape across a line. So, if I were to take this shape and reflect it across this line here, it creates this new shape over here. So, I remember when I was younger doing an activity that really helped me understand this later on. And what my teacher had us do was we had a piece of paper that we folded in half. So that fold line was the line of symmetry. And then she had us put paint um, in whatever design we wanted to do on one half of it. Then while the paint was still wet, we folded the paper over and kind of like pressed the paper down and then opened it up. And essentially, our painting um, because the paint was still wet, created a reflection of the image that we had drawn in our painting. And that's the basic idea of a reflection. And the way that you do it on a coordinate plane is whatever line you're reflecting it across, every single point in the shape needs to be equally distant away from that line. So essentially, like this point C, when you reflect it across the y axis, where it was originally 1 unit away from the y-axis, it's going to also be 1 unit away from the y-axis, but in the opposite direction. Versus this point B was 2 units away from the y-axis, and the reflected point is also 2 units away, but it's in the opposite direction. And you can also, rather than reflecting it across the y-axis, you can also reflect it across the x-axis. So you can kind of see that here. And again, the points are equally distant away from the line with the original points and the reflected points, they're just in the opposite direction. And in middle school, well, I don't think this is actually a middle school thing, but in high school, they do some reflections where it's across a diagonal line. And again, you're equally distant away from that line, but it's more of a diagonal distance because the way that you measure the distance to the line is perpendicular. And so it's a little bit harder to observe the patterns in the coordinates in those cases. So we're just going to stick with rotating it around, or sorry, reflecting it across the x-axis and reflecting it across the y-axis. But know that it is still possible to reflect shapes around diagonal lines as well. Um, because the basic idea is that you're essentially kind of folding the shape and creating that reflected shape, kind of like that activity that my elementary teacher taught me. Um, so that's the idea of a reflection. And again, some of you guys will be exploring the patterns and what happens to the coordinates when you do reflections for your video project. So that's the second type of transformation. And the way that this shows up in elementary math, like I mentioned, is in symmetry and also in identifying what shapes are the same. Because if you have a parallelogram, let's say that's oriented one way, and then you reflect it, some students may not originally see that that's the same parallelogram. And so teaching the concept of reflections can help them identify which shapes are the same, specifically the same in the sense of being congruent. Because there's lots of different ways students might identify the same shape. Like they might say that congruent shapes are the same, but similar shapes are also the same. They're just different sizes. Or you could even have something like having two totally different types of triangles, but they say that they're the same shape because they're both triangles. So using the word same is not very mathematically precise. But if you say that they're congruent, that means they're the exact same shape. They just might be oriented differently. Similar is that they're the exact same shape, but they might be different sizes. And then describing them as both being triangles is kind of communicating that idea of being the same general category of polygon. So that's where reflections can show up in elementary math. And then the last concept that we're going to be talking about is the idea of rotation. So when you're rotating a shape, the way that I kind of like to think about it is that you draw the shape on a piece of paper and then you stick your finger at whatever your rotation point is. So for the purpose of our assignments, today or this week. We're going to have the origin be the point of rotation. It is possible to have other points of rotation, but we're just going to stick with it at the origin. So I imagine like drawing my shape on a piece of paper and then I stick my finger at the origin and then I'm going to rotate the paper around. And that creates a rotated shape. So rotations are the types of transformations that are probably the least intuitive for students to understand because they affect the orientation in multiple ways. Because rotations turn the shape sideways, like kind of in like a circle, versus reflections just reflect it across a single line. And usually it's a little easier for students to understand the idea of symmetry than it is for them to understand the idea of rotations. So on your guys' project, you guys are, and also on your homework, you're going to be exploring 90-degree rotations. So a 90-degree rotation counterclockwise would look like this. And you can see the orientation of that shape has changed quite significantly. If you were to do a 180-degree rotation, it would look like that. And it won't let me move it, but you can kind of see where the shape would end up. And then you could do a 270-degree rotation, which ends up making the shape kind of like that. And I'm sorry that you can't see the whole thing. but you can kind of get the idea of what the triangle would look like. And a 270-degree rotation counterclockwise is the same as a 90-degree rotation clockwise. So on your guys' homework, you're going to explore some of the different rotations, and the 90-degree, 180, and 270-degree rotations are the easiest ones. So those are the ones you guys are going to explore. But if you want to, you can also play around with this applet and explore other rotations as well, like a 60-degree rotation, and see how that affects it. And by the way, the reason why these are called like 90-degree rotations is because if you were to draw a line from the original point to your point of rotation, and then draw another line to the corresponding point, the angle between those two lines would be 90 degrees. And so that's why it's called a 90-degree rotation. Um, and when you're teaching this to elementary students, obviously you're not going to be doing it on a coordinate plane because they don't know about coordinate planes yet. But you can teach it by doing kind of like the finger method that I was talking about, where you draw the shape and then you put your finger on the center of rotation and you turn the shape accordingly. Um, and again, this concept is important because these two triangles are still the same triangle or congruent triangles, even though the orientation is different. So that's just a brief summary of the different types of transformations. If you have any questions, let me know, and I hope you guys have a great day.